Good morning, guys. We are going to do the last part of Unit 4 today. And Unit 4's last indicator is indicator 14. You now understand areas of two-dimensional shapes of the polygons. You understand area of a triangle, you understand area of the quadrilaterals that we have done, like squares, rectangles, parallelograms, and trapezoids. And so now the last part is finding the area of composite figures. Okay, so as you can see, learning target, I can find the area of polygons using different methods to solve real world problems. Okay, so the first way to find area, if something is drawn out for you, you know that area is the number of square units inside a shape. Okay, so if I said this, okay, if this was given to me, all you can do that each is equal to one tile, for example, all right, or 1 inch, whatever the unit has been given. So we could have done 1, 2, 3, 4, and 1, 2, 3, that is 3. We know the area of a rectangle is length times width. So we could have done length times width, which is 4 times 3, and I could have got 12 unit squared. All right, so this is basically how you can calculate using the formula. But another way is when, let's say, it's given to you on a coordinate graph, or you already have the square units inside. Another way is you could count up the number of squares inside the shape. 4, 5, 6, 7, 8, 9, 10, 11, 12. So as you can see, the correlation is just the number of square units inside a shape. If a shape is given to you, which is pretty clear cut like this, all you can do is 4 times 3, which is the formula, because formula always makes things a lot simpler rather than counting up. But if it was a composite figure, and that's what we're talking about, and I'll tell you what that is in a minute, then formulas would be a great asset to have. Okay, so composite figure, it's made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. Okay, so if I give you something like, okay, let's say we have this and we have this that looks like a house. This is actually a composite figure because it is made up of 2 or more two-dimensional shapes. So we have a square here, we have a triangle here. So in order to find the area of this, we would have to find the area of the square, the area of the triangle, and then add both of them up. So that's basically a composite figure. A trapezoid, let's say you did not know or you forgot the formula for trapezoid. A trapezoid can be converted into a composite figure because if I drop a line here, if I drop a line here, look what I have now. I have a rectangle and I have another triangle, one triangle, and this is the other triangle. So I would find the area of the rectangle, I would find the area of this triangle and of this triangle, and I would add it up. And believe me, you will get exactly the same answer if you had used the formula of a trapezoid, okay? So once again, composite figure is a combination of 2 or more 2D shapes, okay? The polygons that you're using. And so when you find each individual shape, you are supposed to then add it up. Sometimes you have to subtract. I'll show you how, and that is when you have a shape given to you and there's a missing part in that shape. So in situations like that, you'll have to subtract. So I'm going to show you some examples. But let's say I have some composite figures given to me over here, and They haven't given me, but you could have done the formula, but gone each by each. You could have found area of this rectangle, area of this rectangle, this rectangle, this rectangle, this rectangle, and this square, and then you could have added it all up, so it made it into a composite figure. Or I could go straight up like this when it's already drawn out in squares. I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So the area of this one is 21 unit squared. All right. Then let's look at this one. We know that this is 1, 2, 3, 4 here. There are 4 here. There are another 4 here, and 4, and 4, and 4. So 4 times 4 is going to give me 16, and then I add another 4, and I get 20. So, or I could have just gone this way. I could have done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's another way that you could have counted. Okay, so this would give me 20 unit squared. Okay, in this one, I can go, let's do the full squares first. And then we can estimate based on the tiny squares. Okay, so 1, 2, 3, 4. Well, this is almost full, so I'm going to count it. So 5, 6, 7, 8, 9, 10. We could make this one and this one 11 when I combine them. I could make this one, and this could have been added here. And this one I could combine it, and a little bit of this, so you would end up with about 12 unit squared. Okay, so this is how. But again, if I had done base times height, the big base plus little base, divided by 2 times height, I will still end up with the same answer, which is 12 over here. Okay, because we have 1, 2, 3, 4, 5, 6. That's my big base. My little base is 1, 2. I'm just showing you the formula. Okay, so this height is 1, 2, 3 here, divided by 2. Okay, and then I would do 6 plus 2 is 8 times 3 divided by 2. So then I would get 1 here, and 4 times 2 is 8, and 4 times 3 is going to give me 12 unit squared. So I just wanted to show you, when you use the formula, or if you're counting like this, you do end up with exactly the same answer. And there's a reason for the formula. It's a shortcut. Okay, because again, think about it. If you're trying to find the area of the entire country and going and counting in square kilometers or square miles, you'd lose your mind. Okay, so that is why we have a formula. Okay, now let's calculate some composite figures. And I am going to give you a shape, and based on that, of course, by now you all know what each shape is and what the formulas are, because we've already done that. Okay, so if I gave you, let's say, something like this and this, all right, and obviously this is inside, so this would probably be shown to you as dotted lines because it's a shape that you can see the inside of that. And then we were given this is 7 centimeters, this is 4 centimeters, okay? And then they would give you something like, of course, you would have the height given to you, and remember what we said. First, they would also give you this and this. Then they would give you something like this and This is 19 centimeters. Okay, so if you look at that, I have told you before that we are definitely not going to take the slant, because whenever you take a height, it has to go up and down straight. Just think about the pediatrician, how you stand again, all right? So if I look at this shape, I have two shapes over here in this composite figure, okay? So I have a rectangle and I have a trapezoid, and I have a trapezoid. Okay, so now when I am trying to find the areas of these two, I have to find the area of each shape first, and then I have to add them on. So if I say rectangle, my formula is length times width. So my width is 4 centimeters, my length is 7 centimeters, so I can do 7 times 4, and I get 28 centimeters squared. Now don't leave it at this, because this is just this spot. Okay, next I have got to find the area of the trapezoid, and so we know that is big base plus little base, half of that to find the average times the height, which is 8. Please don't write 10. Okay, so now we do, my big base is 19 and my little base is 7 times 8 divided by 2. Okay, so 7 plus 19 gives me 26 times 8 divided by 2. I can go ahead and straight up simplify. This is 1. I could have done it here or here, either of those. But I would say if I do this, I get 4. Okay, and then I would have 26 times 4 gives me 104. Okay, because 4 times 6 is 24, carry over 2, 4 times 2 is 8, plus 2 gives me 10, so 104. And then now that I have 28 and I have 104, I'm going to take both these areas, because this is just this spot. Okay, this is just the trapezoid, and I am going to add it up. And here I get 12, carry over 1, 3, 132 centimeter squared is the area of this composite figure. So as simple as that, all you're doing here is you have 2 different, or 3 different shapes given to you, and then you are just putting it together after calculating each individual shape. Okay, so let's do one in which you may have to subtract. Okay, so let's do one in which you may have to subtract. So if I give you a shape that is like this, and then let me go ahead and do this, okay? And this is 13 meters, this is 8 meters, 4 meters, 4 meters, and then we are going to have this area, this part which does not belong because it is shaded off, okay? And this height is 6 meters. Okay, so if I had this given to me and this was the shaded area represents my shape that I have, okay, so if I have this shape given to me and it's saying find the area of this, we can immediately see that the little triangle has been cut off from this shape. Okay, so what we'll need to do is we'll need to find the area of the rectangle, the big rectangle first, this whole thing. Okay, then we'll need to find the area of this little triangle. because it is not part of the shape. That part has been cut off from the shape, and then we'll have to subtract that triangle from the rectangle. Okay, so let's find the area of the rectangle. An area of the rectangle is length times width, and so I get 13 times 8, which gives me 104 meter squared. Okay, now for area of triangle, there is one thing that we need to figure out first. Okay, we know that in a rectangle, the opposite side has exactly the same measure. That's why it's a rectangle. Those are congruent, if you remember. Okay, so if this is 13, this whole thing should also equal 13 meters. But what do we have right now? We have 4 and we have 4. So 4 plus 4 gives me 8. I only have 8 right now. So in order to find this part, I would do 13 minus 8 and I would get 5. Okay? Sorry, 13 minus 8 and I would get 5. I was thinking of the answer when I put that down. Okay, so this is going to give me 5 meters. So now I can see, all right, 5, 4 plus 5 plus 4. Now the whole thing is equaling 13 meters. So that makes sense. Okay, so now that we know what the base of the triangle is, it is 5. So this is going to be base times height divided by 2, which is base is 5, height is 6, divided by 2, and I'm going to simplify 1 times 2 and 3 times 2 is 6, 5 times 3 is 15 meters squared is the area of just the triangle. Now triangle once again is not part of that shape, so we are going to take the area of rectangle and from this we are going to subtract area of triangle. Okay, so I'm going to carry on over here. All right, so area of rectangle, we just solved it and we got 104, and area of the triangle was 15. And so we're going to subtract 15 from 104 and I get 89 meters squared is the area of this composite figure. So this is how we find composite figures, the areas. If shapes are part of each other, you add them. If there is a unshaded portion of that shape that is not part of the figure, in that case, you have to calculate each shape that is there and then subtract the unshaded region from the shaded region. Okay, there's one more problem I want to do with you because this is the one where children kind of make a mistake. Okay, so if you're not careful, now once you see what I'm doing, it becomes really simple. All right, so if I give you a shape which is something like this. And it says find the area of this shape. Okay, so we have 5 inches here. We have 5 inches here. This is 2 inches. And then we have, this is 4 inches. Okay, now please don't try to calculate something weird over here, okay? In the sense that don't try to extend this line and because then you say this is 5 and it's not. Because for it to be 5, it has to go all the way to here, okay? So there's a very simple way to do this, okay? I am going to make this into a big triangle first. So if I did this, look, if I did this, this became a big triangle, right? And so I would find the area of the big triangle and then I would subtract the area of the square or the rectangle in there, which is not part of that shape, because I've added this on to make it easier on myself, okay? So let's first see what would the missing sides be. So here's the thing. If this is 2 opposite side of a rectangle, this is going to be 2 inches also. Okay, because I'm trying to find this entire base. So my base now would be 2 plus 5, and that means my entire triangle base is 7 inches. Okay, same thing for the height. I have got to find the height of the entire shape. So in order to find the height of the entire shape, it would be 5 plus whatever this missing amount is. So if this is 4, this is 4 inches. So this entire height now is 5 plus 4, that is 9 inches. Okay, so now what I can do is I can find the area of the large triangle, which is base times height divided by 2. So this gives me my base is 7, my height is 9 divided by 2. Okay, now when I do 7 times 9, I get 63 divided by 2. Okay, so this is going to be 63 divided by 2, and yes, I am going to end up with a decimal, which is 31 and 5/10. So this is my area of the entire triangle. Okay, now I need to find the area of just the square. Okay, so a rectangle, sorry. So area of this rectangle, area is length times width, and since I'm saying length times width, I have 2 times 4, which gives me 8 inches squared, and this is just the rectangle. Okay, so this is my rectangle, this is my triangle, and now because rectangle is not part of that triangle, I am going to remove it. So I do, and this looks like a rhombus, but I just do it sideways, but this is what I'm talking about. And so 31 and 5/10 minus area of the rectangle, because this is my triangle, this is my rectangle, and I end up with my answer being 23 and 5/10 inches squared, which is the area of this composite figure. So I just want to show this to you. If you have something like this, you can always add on and then subtract the portion that you added on, because you're making it into a shape which you can calculate easily. All right, now the last thing that I want to do in this lesson is sometimes you may be given that the area of make a composite figure with a rectangle and with a triangle, and then you are supposed to use a certain amount of space that is provided to you, and meaning the number of squares that are given to you, and you're supposed to draw in only that much portion. Okay, so let me take my laptop to the smart board because I need to show you over there. Okay, So I'm going to put this here and I hope you all can see. So look what it's saying. Use the space below to show a composite figure made from a triangle and a rectangle with a total area of 16 square inches. Include the dimensions. You cannot add extra columns or rows. Okay, so if I have this, what I can do is, all right, so try to break it apart. Let's say, okay, I want to keep my rectangle. Let's say I do 8 square units. If I do 8 square units, I will need 8 square units for the triangle. Okay, so let's do, if I say 8, that means my calculations on this, if I'm looking at the factors of 8, I could do 4 times 2, right? So if I start over here and I say 1, 2, 3, 4, 1, 2, so I am trying to draw it out. Okay, so I'm just using my formula method. Area is length times width, and I know that 4 times 2 is 8. What does it say? Did it give a square inches? Is 8 square inches. So this is 4, this is 2, so this is 8. Or 1, 2, 3, 4, 5, 6, 7, 8. So I've used up 8 on the rectangle. And now I have 8 left because the total amount should be 16 square inches of this shape. So the best thing to do is, if I need 8, my numerator should have double 8, because in a triangle, whatever the base times height is, you have to divide by 2. So I know that in order for a number to come to 8 after division by 2, the numerator has got to be 16. As simple as that. So I know that area of a triangle is base times height divided by 2. And I know that I'm trying to get my final thing to 8, because 8 plus 8 is going to give me 16. I've already used up 8 for the rectangle, and 16 minus 8 is 8 that is left. So what should I have that when I'm dividing by 2, I should get 8. So look, my base is 1, 2, 3, 4. My base is 4 times what divided by 2 gives me 8. Okay, so 4 times 4 is 16. So that means my height should be 1, 2, 3, 4. Okay, because then look what happens when I do this. I end up with 8 inches squared. So my base is 4. 4 times 4 is 16. Remember, we said that a triangle is half a quadrilateral. So then we are just going to do this. Okay, and if I count this, I have 8, 9, 10, 11, 12, 13, 14, 15 and 15, these two, and these two will give me 16. So look, so whatever it is, you are taking that and you are figuring out as to how you can convert it into a composite figure using the squares that were given to you. So let's try, well, we can do another one. All right, that did not work, so I will have to use this to get out of there. And okay. All right, let's do this one. So this one is saying you need a total of 24. So you need a total of 24. Okay. So this is 24 square inches is what you need to make when you are using a rectangle and a triangle. And so let's think about the factors of 24. 12 times 2, or well, before 24, let's just figure out how we want to break it apart. So let's say I think 12 and 12, or you can do whatever you desire as long as it is giving you the area that is asking, because you're making a composite figure. So if I do 6 times 2, okay, let me just, okay, 1, 2, 3, 4, 5, 6, 1, 2. So this gives me this part. So this 6 times 2. So area of rectangle will be 6 times 2, which is 12. Okay, so this is 12 inches squared at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got the rectangle. So if I've got 12 used up, I have 12 left. So this is 12. I need another 12 on the triangle to give me a total of 24. So in order to get 12, I know that whatever I'm dividing by 2, the base times height, should be double of 12. Okay, and double of 12, that means if my base is 6 times what is going to give me a number that is divisible by 2. So if I can look at this, I know that 6 times 4 is 24, and if I divide 24 by 2, I will get 12. So that means my height, because this is base times height, is going to be, you can do it here or you can put it anywhere. It doesn't mean you can put the height in the middle over here also. Now let's say I do it this way. 1, 2, 3, 4. That's my height. Okay, and my base is 1, 2, 3, 4, 5, 6, and then all I do is I connect like this, and there is your shape, because you have 6 times 1, 2, 3, 4 divided by 2, 24 divided by 2, you get 12, and 12 plus this 12 gives me 24 inches squared as my area. So that's about the stuff that you'll be doing in this lesson, and that's why we were saying that the learning target, I can find the area of polygons using different methods to solve real world problems. Remember, once again, a composite figure is a shape which is a combination of a couple of, maybe 2 or more two-dimensional shapes, and you already know how to calculate the area of each shape. So all you're doing is calculating each individual shape and then adding it up. Or if there is an unshaded portion that looks like a part has been cut off from the shape, find the area of the 2 shapes and subtract. So that's basically what composite figure is. And this concludes our Unit 4. All right, guys, we will start Unit 5 tomorrow. Have a great day.